And I got that. Okay, thanks, Noah. So our winter weather presentation tonight is basically going to walk us through winter weather measurements and how to report the various parameters that we do measure. So again, nothing about this particular presentation is Illinois centric. So it applies to anywhere where we're getting snow or winter precipitation. So as we go along, there's gonna be a lot we're gonna cover in a way. Some of it, if you've been doing CoCoRaHS for a couple of years, will be should be familiar. If you're new to being in CoCoRaHS during the winter, some of this will be new. And again, as Noah said, we'll provide links and resources to this and other materials at the end that you can review, even as much as watching this again if you wanted to. So we're going to start here with what exactly we're going to cover during this webinar. So what we do plan on covering is how to measure and report daily precipitation when it's snow or sleet. We're also going to talk about measuring and reporting new snowfall specifically. And I should mention that most errors folks make in CoCoRaHS, when we have a QC program that looks for suspect data and flags it and tries to correct it. Most errors are not measuring errors. People aren't making mistakes measuring the snow necessarily or measuring rain. It's how it's reported, and that can get a little tricky. So we're going to go over that quite a bit. We're also going to talk about snow water equivalent, what it is and what it is not. And it may not be what you think it is. Talk about measuring the total snow and ice on the ground, or what we're going to call snowpack. Freezing rain is something that's fairly common in the Midwest and Northeast, and probably at least once this winter in those areas, you're going to have to measure, you're going to have a situation where freezing rain will occur. And then we'll have a section on special situations that might arise, for example, mixed precipitation, high wind situations, et cetera, and how to handle them. And last of all, we're going to have some tips that should make winter weather measurements a lot easier than they are if you don't use those tips. So preparing for winter measurements, we're already here at the 2nd of December. We had a cold November, not too much snow around the country, generally below normal in most areas, but and a warm day today here in the Midwest, 60 for me today, but winter's on the way. And in fact, there's snow in the forecast over many parts of the country next week. So when we get into colder weather now, where temperatures are consistently below 32 at night, for example, it's a good idea to remove the funnel and the entering measuring tube from your rain gauge. Just leave them inside. Don't worry about putting them back, bringing them out. Unless we get into an extended period of warm weather where it's going to rain, you might want to put them back out. But if you have water freeze in the entering measuring tube of any amount, like say a 1/10 or a 1/4 inch, 25/100, that could crack or break the tube. I had one that just blew the bottom out of it. So you don't want to leave that out, especially if it's raining and it's going to freeze overnight, for example, a hard freeze by the next morning. You want to remove the funnel and the inner tube if snow is expected. Snow will quickly clog that 1/4 inch opening in the funnel and then prevent snow or melting snow or anything else from getting into the actual entering measuring tube. So good idea for the winter is, and if you're in a winter weather area, just pull the tube and the funnel. If you're in a warmer climate where you might see snow a couple of times a year at most, you can leave it in most of the time, but pay attention to the forecast. And when snow is forecast, and go out and pull that in before the precipitation starts. If you're going to be in an area where you're going to get some snow, or you typically get snow during the winter, a simple snow measurement board can be set out right near your rain gauge. That gives you a flat surface on which to measure the snow. We don't want to measure in the grass because your grass has a depth to it itself. And if you push a ruler all the way down into the grass, you may be adding 2 inches or 3 inches to whatever you're measuring because it's sitting on top or not the bottom. So having something flat like a board, which we'll talk about here in a second, or even a well exposed outside table, something that's not going to get drifted on by the snow off the roof or something else, that can be used as well. But this makes it easier if it's right near the rain gauge. And if you do use one, you want to be sure you mark the location with a flag or some sort of reflector. Here on the left here is a snowboard with a little bit of snow on the ground. Probably, I wouldn't even know if that might be a tenth. And the board is clearly visible. You can see the reflector there marks the corner of the board. But you get about a half an inch or 3/4 of an inch of snow, and you can tell where the board is, but it's hard. It's getting harder. And if you would have had another inch of snow, you would not know where that board was without a reflector or some sort of marker there to tell you. So it's always a good idea to mark it. And if you have one, good idea to put it in early so that you're not trying to shove a stake into the ground when the ground is frozen. You're going to need something to measure the depth of the snow with. We have something called a snow stick. It's a ruler that's graduated in tenths of an inch. The one here in the photo is about 40 inches long, and it's marked in tenths, and also half inch. There's a 5/10 mark there. And this makes measuring snow depth really pretty easy. You can get these from weatheryourway.com, who's our main CoCoRaHS supplier, and they have them available. But if you're not in an area that gets a lot of snow, this is not something probably you want to get. So you can use a regular ruler and just convert the eighths and quarters and sixteenths into decibels. So if you have 2 3/4 on the ruler, you would round it up to 2.8. So, and I think we even have a chart, I'll have to dig that up somewhere, which converts eighths and stuff to tenths. So you can do it off a table rather than dividing it out. But at any rate, you can use a regular ruler, but a tenths ruler really makes it a lot easier. And I've seen those in office supply stores. You can buy a 12-inch ruler that's marked in tenths, so they're available. So let's talk about winter precipitation types. There's several different types. Snow is the primary one, and snow really represents quite a bit. But snow are small white ice crystals formed when supercooled cloud droplets freeze. And they have different shapes, and that's dictated by the temperature in the cloud at which they form. There's a specific zone aloft, which we call the dendritic growth zone, where snowflakes form, and the temperature of that zone and amount of moisture depends on what kind of snow crystals you get. Lots of fascinating stuff on snow crystals in the literature and popular publications. Then we have snow pellets or grapple. These are one and the same. Grapple is a more formal term. These are white opaque ice particles. They're white. They're sometimes I've seen mostly spherical ones, but they can be conical, and they form when supercooled water collects on ice crystals or snowflakes. So because they're somewhat hollow after that they form, they typically bounce when they fall, or they'll break apart. They look like tiny little pieces of that pellet plastic sometimes. But they're very distinguishable from regular snowflakes if you see them, especially on a dark surface of your windshield. But that's another common thing we see during winter. Snow grains, a little less common. These are very small, white, opaque particles of ice. They're more flattened and elongated than snow pellets, and they typically form in situations that are similar to ones that produce drizzle in warm weather. Low clouds, perhaps a disturbance aloft moving through, which if it was warm enough, it would be drizzle, and these little snow grains form in the cloud, and they can be very fine. They may be hard to see, but might accumulate a little bit on the sidewalk, probably never enough to measure, but that's one other form. To call it snizzle because it is, to me, the solid equivalent of drizzle. Then we have sleet or ice pellets, which is fairly common, and those are small balls of ice that form from the freezing of raindrops as they refreeze, moving through a warm below freezing layer of air near the Earth's surface. I could show a diagram here, but I won't because we get into too much of that. But basically, they may be snowflakes. They fall through a warm layer and they melt, and then they refreeze as they fall through a cold layer near the ground. That's why we typically see this in transition zones between rain and snow. So if we have rain changing to snow, very often it'll be rain changing to sleet for a brief period and then the snow. And there'll be a mixing period in there too. Out on the East Coast, it might be just the opposite. They may have snow going to sleet and then freezing rain as warm air comes in off the ocean. But it's generally a transition type precipitation. So if you're getting sleet, you're either going to or have had rain or snow on either side of it typically. For measurement purposes, all four of these are treated as snow. So if you have an inch of sleet, you measure and report it the same as you would snow. We don't have a separate category for sleet or any of these. They're all reported as in the snow category. You can tell us what you had in your comments. If it's just sleet, you can say, I had an inch of sleet or a half inch, whatever it is, in the comments to identify what kind of precipitation you had. But all four of these are treated as snow. This one is not. Freezing rain, which I don't know that anybody really likes because of all the disruption it can cause, occurs when the surface temperature is below freezing. And there's a warm layer of air aloft, and the precipitation is coming down as rain, it's liquid, but as it falls through this cold layer, the water becomes super cooled and then freezes upon impact with surfaces, the trees, the power lines, your car, the sidewalks, and the roads. Freezing rain is liquid precipitation and should be measured as you would measure rain. That is, melt what's in the gauge and then measure that and report that as your precipitation. You can report a thickness of ice on trees and branches. We'll get into that a little bit later, but we're not going to talk too much about that. But there will likely be in the future here some more information coming out about chances, opportunities to measure and report freezing rain. So now we're going to talk about some more specific terminology with respect to snow measurements. If you haven't been through CoCoRaHS in the winter yet, it's new. And actually, if you have been through CoCoRaHS with a winter, some of this will be new. We are trying to standardize our terminology, and we're going to be doing this across the input forms, training, the reports you see. So we're going to start using this, but you'll see what we're talking about here shortly. So a gauge catch is the amount of water in your gauge measured after it is melted. So if you get snow, all in snow, and then you've got a little layer of snow together, let's say you got 2.5 inches of snow in your gauge, you melt that, and that's your gauge catch. That's what you usually report as your daily precipitation. Your 24-hour snowfall is the maximum depth of new snow in the past 24 hours. That's, I think, hopefully pretty clear. Your 24-hour snowfall snow water equivalent, and this is sort of a new tag by putting the 24-hour on there. This is the amount of water measured from melting a core of snow obtained from the snow on the ground at the depth of your 24-hour snowfall. So if you measured 3.5 inches of snow on your snowboard, you would take a core from a spot on your board there where it's 3.5 inches and melt and measure that and report that as your 24-hour SWE. Your snowpack depth is a total depth of new snow and old snow and ice on the ground at observation time. So this is an observation we would take every day that there's actually snow on the ground. Sun shining, not a cloud in the sky, and you have 6 inches of snow on the ground, you report your snowpack depth that day. And then there's another parameter called snowpack snow water equivalent, or we call snowpack SWE. And that's the amount of water measured from melting a core, same as the other one, but this is obtained from a location that's equal to the snowpack depth. So after you determine how deep your snowpack is, you take a core from a spot that is representative of that depth, melt it and measure it and report it. And we'll get more into how that's done here shortly. Your daily precipitation. So snow is precipitation, but you got to remember that not all precipitation is snow. So we differentiate in our observations. The most important measurement that you can do is the amount of water in your rain gauge, melting that snow that's in that gauge in that photo. That's your gauge catch. So you have to melt it or weigh it, and we'll talk about that too. But you might have, for example, 3 inches of snow in that gauge there. It probably looks a little bit more in that gauge, but that might only melt down to 28/100ths of an inch of water. And that's your daily precipitation. That's your gauge catch. And that gets reported on the form, on the precip report form. For those of you who use the mobile app, there are corresponding fields on the mobile app. I don't have mobile app images here to show you, but if you have the mobile app, you could almost follow along with your app on. But that's where you report it. Where you normally report your rainfall is where you report your gauge catch, your melted snow and whatever else is in there. So what is the 24-hour snowfall? It's the maximum accumulation of new snow and ice in the past 24 hours prior to melting or settling. And this is the tricky part of it. And this is where we don't have necessarily problems, but observers sometimes have a little trouble understanding this because it's snow and it's winter and it's different than rain. But the key words here are prior to melting or settling. So we want to measure the new snowfall as soon as possible after it ends, before the settling and melting occur. So that means it won't often be at your regular observation time. If the snow falls and ends at 6 p.m. and forecast is for clearing skies and much colder overnight, blah, 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 you should go out and measure your snow at that time, because it could blow away, it could settle, conceivably, depending on what's going on, could melt by the next morning when you make your observation. But we want to capture that maximum depth. So we ask observers to measure it as soon as, reasonably soon after it falls as they can. One thing to note, and we don't see this very often, but every once in a while, an observer will measure the depth of snow in the rain gauge itself. Go back a slide or two with that rain gauge with the snow, they will stick a ruler in the rain gauge and measure the depth of the snow in there. And that's not allowed. It's not permitted. It's not accurate. It's not representative. You have to melt what's in the rain gauge to measure it. I like to tell people, if you don't want to mess with winter precipitation, you don't want to measure snow and all the process that goes through with it, you don't have to. If you don't feel safe doing it, if you don't feel comfortable doing it, you don't have to do that. What we do ask you to do is bring in your gauge, melt what's in there, report that as your gauge catch, your daily precipitation, and that's it. You can mention in your comments it snowed and put an estimate in there. But if you don't want to get the equipment or take the time to measure snow, there's nothing that's forcing you to do that. So to illustrate this maximum depth, we're going to have a little tiny animation here, which will show you a progression of a little snowstorm that goes through and what you should do. So on Monday, we have snow beginning at about 9 a.m. in the morning, and it proceeds to snow for about 4 hours until 1 p.m. in the afternoon, at which time there's 2.4 inches of snow on the ground. Then good old sun comes out and temperatures get up, it's bright and sunny and temperatures are getting the upper 20s or whatever. And we start seeing some settling and melting of that snow. Actually, probably be more than the upper 20s to melt that much. But during the afternoon, it melts down or settles. And by the next morning at 7 a.m., there's only 1.2 inches of snow on your snowboard. So what you should do is measure the snow as close to 1 o'clock as possible, somewhere around here, to capture that maximum depth. What if you're not around to do that? If you see it or you can estimate it, that's fine. If you're not around, there's not much you can do. Very frequently we'll have snow that ends at 2 in the morning. And, it's another, 4 hours, 5 hours, until 6 hours in some cases, until you make a measurement. Yeah, you can have melting and settling, and you come in and you'll find 1.2. What do you do? In most cases, you have to report that 1.2 if you haven't made a measurement. However, if you know there was definitely more snow than that, you can leave your snowfall as NA and indicate in your comments 1.2 inches on the ground this morning. However, there was probably at least twice as much of that, late yesterday afternoon, but I was not able to measure it. That's fine. That's what we would like you to do. But ideally, we want you to capture the snowfall at the time, close to the time it ends, at least the major part of it at its end. So where do you measure 24-hour snowfall? If you're me and have a pretty good size area, a lot to move a snowboard around in. It's not too difficult, but you want to find a nice level place where drifting or melting has not occurred. If you have a snowboard out, they are usually very good at catching a nice layer of snow, even in moderately breezy conditions. If it's a howling snowstorm with 20 to 25 mph winds and a very dry snow, your snowboard could be bare while you've got snow everywhere else. That's just the nature of the game. But not all the snows are like that, and not all of them are like this one that Nolan's measuring. Everything settles nicely on a nice thick layer of snow. But you want a flat place to measure. And if there's not been much wind, for example, an outdoor table might be sufficient to do that with. You want to slide your snow stick or ruler into the snow until you reach the board or the ground surface. Again, we'll be careful of grass, and we'll talk more about that a little later. You read the value on the snow stick to the nearest 1/10 of an inch. So like 3.4 inches, although in this case, the focus isn't good, but that's probably closer to 6 or 7 inches that Nolan's measuring there. And you should take several measurements and average them. Even across a snowboard, which is generally about 2 feet by, 1.5 feet, 24 by 18 inches in general. There could be differences of a 1/2 inch, just depending on how things, the wind blew a little bit. So you take several measurements on the board until you're fairly confident you have a good representation. You average them, and that's what your depth is. And then if you're using a snowboard, you clear it off and you set it back down on top of the snow near your marker so that you're ready for the next snow. What I do is I have my reflector in the ground. I have a reflector on a fiberglass post, and I rotate the board around that reflector. So if I clear off the board, I'll just move it. If it's at the northwest corner, like it is here, just assume that is the northwest corner that Nolan is showing there. I would move the board, east a little bit more and put it at the southwest corner. So you can rotate it around so you don't have to pull your marker out of the ground. If the snow's deep enough, you can just put the marker in the snow, but just have to use your judgment and you do what works best for your situation. But you want the board on top of the snow. Don't put it back in the hole that you excavated to clear out the board. That will affect your measurement. So you report your snow in the new snowfall section on our daily report form in the line accumulation of new snow in inches to the nearest 1/10. And it's also, and we tell this to everybody all the time, it's really a good idea to include comments wherever you can. We find that comments extremely helpful when we're QCing the data. They're very helpful to people who are looking at the data and trying to understand what's going on. The fact this was very little wind and there was a good gauge catch, both tells me that the precipitation is probably really good and the snowfall depth is good because there were no real complications. If the wind's blowing and it was a really dry snow and the gauge didn't catch much, then we have a whole different ballgame, and we know that's difficult. But some messages or comments like this really help us zero in on the quality of the data. So what if it's snowing at your observation time, or it's snowing during the day and you want to send in a significant weather report or a storm report to the National Weather Service? Frequently during storms, we'll send out notes to folks, and the Weather Service will ask them to send in significant weather reports. So what you should do is you can take your snow ruler and go out to your snowboard or wherever you're measuring the snow and measure your snow. Write down the time of your measurement and the amount. And you can report the amount since the last time you measured. If it's your first measurement, it could be the amount since your observation that morning. But you can go out as many times as you need to. Some storms, I'll go out every hour to measure the snow if it's snowing steadily and accumulating. But do not clean off the snowboard or the spot you're measuring from. Your snowboard should be cleared only once every 24 hours at your regular observation time. This is also National Weather Service policy. There are some areas where they allow stations to clear a board no more than 6 hours. No sooner than every 6 hours. But generally that is discouraged because cleaning the board frequently will inflate snow totals, because you will get some settling during a storm as the snow packs, and the weight of the snow compresses it a little bit. So you should only clear your board every 24 hours. If there's a reason to do it, it should be at least 6 hours since your last measurement. So we don't want people going out clearing their boards every hour and reporting new snow like that. Another thing I want to talk about is what I call the 10-to-1 myth. We know there are people out there in CoCoRaHS and probably elsewhere that use the 10-to-1 ratio to 10-to-1 occurs. It does. We know it does, but it occurs a lot less than you might think. This map here was constructed by a professor at St. Louis University and some students do a 30-year climatology of snow to water ratios. The area that is 10-to-1 is the light blue that's sandwiched in between the dark blue, which runs through the upper southeast there, and the maroon, which runs along the Ohio River there. That light blue is the only area where on average there's a 10-to-1 ratio. Most of the country has a much higher ratio, like 13-to-1 or 14-to-1 or even 20-to-1. So do not in any circumstances use 10-to-1 to estimate your snowfall. If it's a really wet snow, it could actually be 6-to-1 or 8-to-1. So we don't want you doing that. And if you can't directly measure the snow, then you can include estimates and comments in your observation, but don't enter a value. The snow water ratio is really dependent on a lot of factors, and it's not just what the temperature is at the surface. If it's 32 at the surface, doesn't mean it's 10-to-1, and if it's 20 at the surface, doesn't mean it's 15-to-1. It can vary quite a bit even within the same storm. A couple of years ago, I went out and measured snow. We had snow overnight, and it was still snowing at odd time. So I made my measurements, grabbed a corn, went inside and took care of that. And it was still snowing for another several hours. And I went back out 3 or 4 hours later and the snow had stopped. So I took another core. The core I melted in the morning was, I believe it was about 13-to-1. It was 13 inches of snow to 1 inch of water. The core I mentioned from the second half of the storm, or second part of the storm, was more like 7-to-1. So even within the same storm, that can change. And that's because warm air may be moving in a loft or colder air may be moving in a loft, depending on the situation. So don't rely on that 10-to-1 myth. And we know people do it because you can see it. It doesn't happen as much as it sometimes appears in the data. So here's the big one here. Measuring the 24-hour snow water equivalent, or 24-hour SWE. This is not the amount melted in your rain gauge. We have a lot of people that measure what's in their rain gauge, write down 0.26. They write in 2.5 inches of snow, and then they write in 0.26 snow water equivalent. And that's not correct. If you don't take a core of snow and melt and measure it, this is a separate measurement from the gauge catch. If you don't take that core, you have not measured SWE, and you should not enter anything in that field. It's always obtained by taking a core of snow and then melting and measuring it. And the thing to remember about this is very often what you get from a core will not be what you got from the rain gauge. The gauge catch will not necessarily match the core. They will sometimes, and that's fine, especially if it's a nice, calm, straight down snow and everything accumulates nicely and falls in the rain gauge nicely. But more often than not, they are going to be different. And probably the majority of the time, if you do a core correctly, the core will actually have more water in it than what falls in your rain gauge, just because the rain gauge is not an efficient collector of snow, especially when there's any kind of wind. So how do you do this? You use your snowboard or other hard surface, and you take the core after you measured your snow depth. As I explained earlier, if you measured 3.4 on the board, that's what you determine your depth of new snow is, your 24-hour snowfall. Then you find a place on your board where it's 3.4 inches, and that's where you take your core. So you capture the core. You can't see the snowboard there, but there is one, and he's got a marker there. By inverting the outer cylinder and pushing it straight down into the snow. And then use something like a spatula, or we have what's are called snow swatters, I think they're still available, to slide under the opening of the cylinder, trap the snow in there, and invert it and flip it over and capture that core. And if you do it well and you capture all of it, the depth of the core should be your depth of your snow, plus or minus a tenth as it's going down the rain gauge. But and there you can see where the board's been cleared and he's sliding the spatula under, or the snow swatter. And then you melt and measure that and enter that in your melted value from the core to the nearest hundredth. And that's your 24-hour SWE. And this will be one of the things that you'll be seeing pop up on these forms, probably not in the too distant future. You'll see this new wording showing up on the forms as well. So that is not your rain gauge value. That is what you get from melting a core. So measuring the snowpack depth. This is a total snow and ice on the ground, new snow as well as old snow. And this is a measurement you'd make every day as long as there's still snow on the ground. It's an average depth of snow. So you're going to have to take numerous measurements, maybe more than 3 or 4, depending on what the situation is. This is a storm we actually had here in Illinois and down here in Champaign County several years ago. Lots of wind, as you can see, lots of snow, and that in many cases would be a nightmare to measure or try and measure accurately, although you can see some areas there that are fairly uniform. But this is the type of thing you'll have to deal with sometimes. And there's folks on here attending the webinar, live in open areas on farms. You know what I'm talking about. Might have snowed for 24 hours, but you also have a lot of dirt from the next county over showing up as well. So measuring snowpack depth. So since it's fairly rarely uniform, you're going to need to take a number of measurements, and I've taken as many as 10 to get a good average, and then average those to get your total depth of snow. Always a good idea to get a notebook for making snow measurements, even if it's going out to make your new snow measurements, or whether they're making your snowpack measurements. A notebook and pencil is always a great idea to write things down. Some people might dictate into their phone or take a photo, but you're not going to take 10 photos, I don't think, of your snow stick to average them out. Writing down seems to be a lot more convenient. So you want to make sure you get through all the layers of snow, because as snow sits there on the ground, the bottom layers will actually become icy and convert to almost just solid ice, depending on the situation. So you have to make sure you get that ruler down through all those layers. But you want to make sure you're not below it through grass. If the snow's all the way through the grass to the ground, that's okay. But if it's perched on top of the grass, you want to make sure you're not measuring the grass. So you read the value on your snow stick and record those values to the nearest ½ inch, because we measure the total snowpack depth to the nearest ½ inch. The Weather Service reports this to the nearest inch. So there's a little difference there between CoCoRaHS and the Weather Service on this, but either way, we're trying to capture the average depth of snow in the area you're looking at. You don't want to measure artificial accumulation, such as something that's been plowed or where you shoveled snow, or unusually large drifts that obviously are due to excessive wind and not due to a lot of snow. That can sometimes be a little difficult, because you will have for example, I have a yard that, depending on which way the wind's blowing, drifts in different places and deposits snow differently. And so you will have areas that have drifted and areas that are thin. Those are okay. Large drifts that we're talking about, might be up against a building or up against your car or up against something else that if it wasn't there, you wouldn't have that drift. So you want to avoid that. Also, if you use a snow thrower and you're throwing snow into your yard from the driveway, you don't want to measure where you were throwing snow either. So as things go on, we'll eventually get to days like this where the snow is starting to melt off, and you're going to have a day with snow only partially covering the ground. And to accurately determine the snowpack depth, you want to determine the average snow depth in the snow-covered areas And then you use that percentage, whatever percentage of ground is covered, multiply that by that percentage to get the average snow cover, because the average for the bare areas is 0. No matter what percentage that is. So if you estimate, for example, that 60% of the ground is covered by 2 inches, you've measured that, you've got your average. The rest of the ground is bare. Your total depth you would report is 2 times 0.6 or 60% or 1.2 inches. So you're just taking what proportion of the ground is covered and then calculating that percentage of the total ground to report your actual snow. If more than half the ground is bare, it gets really easy. You just report a T or trace of new snow, and you can mention the range of depths in your comments. You report a trace of snow until the snow is gone, unless you're looking at some artificial pile that's, was plowed at the end of your driveway and it's still going there, well into May or something. Any naturally deposited snow visible would be counted as a trace. So it doesn't have to be a 1 foot square area. It doesn't have to be a 6 inch square area. If there's visible snow that hasn't melted yet, you report a trace of snow if the ground is more than 50% bare. And you report your snowpack on the form just below the new snow section, and your total depth of snow and ice in inches to the nearest ½ inch. I believe this field will let you enter to the nearest 10th, and there's nothing to stop you from doing that. I'll tell you right now, in the official records, like they go to NCEI in the archives, that'll get rounded down or up depending on where your 10th falls, but we want you to report to the nearest ½ inch. Reporting the nearest 10th implies a precision that really probably isn't there when you're measuring snowpack. Which is why the Weather Service generally goes in an inch increments. But that's where we report it, and you report to the nearest ½ inch. And then there's the 24-hour snowpack and snow reminder, again, about the grass. This little illustration, I'll show you what I'm talking about. You want to measure the snow only, not the snow plus the grass. So early in the season with a light snow, you're probably going to get this situation where you're going to have to be careful about what you're measuring. If it's been cold for a while, you've had several snows, that'll probably, and depth will probably filter down to the ground at one point, and you can measure all the way to the ground. So just be careful that the snow isn't always perched on top of the grass. So measuring snowpack, snow water equivalent is very much the same as measuring the 24-hour SWE, but it's a measurement that's really useful to hydrologists and river forecasters. And it's why we promote what we call SWE Mondays during the winter, to encourage people to take this measurement and report it, because it is used by the National Operational Hydrologic, we call it NORISC. I can't remember the entire acronym right at the moment, but they use this every day to help make their calculations of amount of water that's sitting on the ground in the form of snow and ice. And that's what hydrologists and river forecasters use in their models, especially as we get closer to spring and we're going to get runoff into rivers and streams. It provides an estimate of how much water is on the ground. And there was a situation a couple of years ago here in the Midwest where we had a February where there was a lot of 4 to 6 inches of snow on the ground, but it had about 2.5 inches of water, which is a lot. And then we had 3 days of rain on top of that. So you can imagine that created quite a mess, a lot of flooding, in some places a lot of damage. But knowing how much water was sitting on the ground, 2.5 inches, was very helpful to the hydrologists and river forecasters when they had to factor that into their rain forecasts. So we don't tell people this has to be done every day. You can do it every day, but you should measure it after each new snowfall, because you're adding new snow to the snowpack, and then once a week after that. Again, we usually have SWE Mondays where we ask observers to report that, so we get a nice representation once a week of the water on the ground, so to speak. The process is the same as measuring 24-hour SWE. You take a core, you melt the core, and then you measure that water. you don't want to have an area that's been drifted, melted, or blown clear. Obviously, there'd be nothing to measure, but you make your snowpack depth determination, and then you find an area that is equivalent to that depth. So if you find an area that if you've got 3 inches of snow, then you find an area where there is 3 inches of snow and take your core from that spot. And again, it's the same process. You won't have a snowboard to do this on. I'll touch that one in a minute. So you're going to probably do this from the grass. Same process, you push the gauge upside down and push it into the snow. You clear the snow from around the gauge, you slide a spatula under, you lift it and flip it, and you've captured your core. In this particular situation, you can see all the grass there. And you will capture grass and debris with your snow core. Don't worry about that. It's not critical. That's why we only measure this to the nearest snow depth to the nearest half inch. You're measuring, this is sort of not a crude measurement, but we're not as precise as we are with rainfall or even new snow. So don't worry about grass or stuff in your sample unless you get a big clod, and then obviously that would affect something. So you melt it, measure it, and you report it right below where you reported your snowpack depth. And those are two separate measurements that shouldn't match anything else. Unless it's the first snow of the year and you're measuring it, this might all match up. But you don't report this unless you actually take the core again. So special situations, and there are many of them. See, in this situation, there was lots of wind, there was freezing rain with lots of ice, and there was lots of snow. This was the day after we launched CoCoRaHS here in Illinois. This was at the National Weather Service in Lincoln. They had quite a storm to kick things off. So as you may know, windy conditions are really a pain when you're measuring snow. There are times I've gone out there in a windy snowstorm and basically threw up my arms and said, I don't know what I'm going to do here. And you just have to sort of do the best you can. So you're going to have a situation where you're going to have hardly any snow in the rain gauge, and you won't be able to melt much out of it, but you know you had more snow than that. If it snows for 12 hours and you only have a couple hundredths in the gauge or a tenth in the gauge, and you have a lot of snow laying around, you know something's not quite adding up there. So you have to think this through a little bit. This is a case where you really should take a core sample from your snowboard or an area representative of the average depth of new snow, which may not be on your snowboard, by the way. And because the our 4-inch rain gauge is not a very efficient receptor for snowfall and windy conditions, this is probably the way to go in most situations. You take that core, and this is one of the best reasons for doing it, and melt and measure the core sample. And if you feel this, it's more representative of the actual precipitation, which if it's really windy, it will be more representative, then enter this as your daily precipitation and make a note in the comments that you've done so. And then include whatever you had in your rain gauge, your gauge catch in your comments as well. Here's an example. Okay, 3.6 inches of new snow, but there's only 600ths in the gauge because of wind. So clearly it wasn't, that dry of a snow, because when we took a core sample of the new snow, it was melted down to 2100ths of an inch. Well, that is certainly more reasonable than 600. So we enter the 2100ths in the daily precipitation field, the total rain and melted snow, and enter in the comments that we did take this precip is from the snow core. We only got 600ths out of the gauge, and because of winds, this core is a more accurate representation of the daily precipitation. And this may happen a couple times, once or twice during the winter, may not happen at all, but this is an option. So if you're scratching your head over how little is in the rain gauge and you got something reasonable from a snow core, then you can use the snow core. So we get this question a lot, or we see comments, oh, I had snow, but it didn't melt, it melted, so I didn't have any snow. Well, if it snows, you had snow. But what if it never accumulates? Temperature's 33 degrees. and it's not snowing that hard, so it's melting as it hits the ground. You report your gauge catch as your daily precipitation. You report a trace of new snow, because it did snow, but it did not accumulate. Or if it accumulated, it was so brief, you could not measure it, so it's a trace. And then you're in your comments, you should write snow melted as it fell. And you can put your the times in there and whatever else you want to add. What if you have snow or sleet mixed with the rain and it doesn't actually accumulate on the ground? You'll see this sometimes during the winter in a transition situation. You'll get all three. You'll get snow, sleet, and rain all at the same time, but nothing, no snow or sleet is accumulating. It's the same situation. You report your gauge catch as your daily precipitation, and you report a trace of new snow. Remember, snow and sleet are treated the same when it comes to reporting and measuring. And then you make a note in your comments that they were mixed, but melted as it fell. So what if there's snow and rain that mixes and there is snow that accumulates? Well, different side of the question. Well, clearly we always report our gauge catch as daily precipitation. That's the first one, always the same. Then you report the maximum accumulation of the new snow as your new snowfall. So again, this is where it's maybe really important, because you're in a borderline situation here probably with temperatures, that you get out there as soon as possible. And this is the part, possible, after it ends, before it has a chance to melt, to measure it. But if you can't measure it before it melts and you have an estimate, include that in your comments, but do not enter that as your observation. If you don't measure it, it's not an observation. As far as a digital observation, you can enter it in your comments. You enter NA for snowfall, and then and say, I estimate, there was an inch, but it melted rather quickly because it changed to rain right away, and the rain washed it all away before you could get out there. There's lots of situations like that, and we just ask everyone, do the best you can, and if Mother Nature doesn't cooperate, there's not much you can do about it. But this is the procedure for if something like that happens. Always, comments are always helpful, no matter whether you're talking about snow or a thunderstorm in the summer, or whatever's going on. Comments about your observations are always helpful. So some other things. What if you get snowfall of less than 1/10 of an inch? That's reported as a trace. Now, in that first photo I showed you of the snowboard, where you can see the snowboard and the snow on the grass and the reflector, that might have been 1/10 of an inch, but it might have been traced too. The thing is, if you see a few flurries, one flurry, one crystal of snow falling on your windshield, or you're outside working and you see 2 flakes of snow on your coat, that's a trace of snow. That's a trace of rain if it was rain. Snow does not have to end up in your rain gauge to be counted as a trace. So just because it snowed on you in the front yard, your gauge is in the backyard, and there's nothing in the gauge, doesn't mean you didn't have any snow. Sometimes, and you'll see this, and especially when the snow is very dry, it's been cold, it's very cold, and the snow is dry, high snow to water ratio, maybe 20-to-1 or more, or 15-to-1. You might have a measurable snow on the ground because the snow is light and fluffy. You might get a couple of tenths, even 1/4 of an inch, but more likely 1/10 or 2. But only a trace, and you go, wait, how can this happen? Well, if it's windy, that would be one reason. If the snow is very dry, it just doesn't have much water in it, and that's what you measure. So that can happen. So that can throw you at first if you're not expecting it. Freezing rain. This is a tricky thing from several standpoints. We don't report it as snow, and we don't have a field on the form to report freezing rain. So what you have to do is measure and melt and measure the water that's inside, on the inside surface of your gauge, and report that as your daily precipitation. Now, this was a pretty substantial ice storm in this photo, and I forget where this was taken, but there's a lot of ice there, and it looks like there's probably a 1/2 inch of ice almost on the wire fence there. So the first trick is getting your gauge off of the bracket. And we have several tips for doing that. You carefully pour warm water on it to loosen the bracket, and then bring the whole thing in to melt down. You got to make sure that you're not measuring anything on the outside of the gauge. So you can let it sit in the sink until it melts and then measure the rain inside. The second thing is your safety. We don't want people going out in an icy situation like this, where there's a high risk you're going to fall and hurt yourself, or be hit by falling power lines or tree branches. Your safety is paramount. So in a situation where you have serious freezing rain, just leave it until it's safe to go outside. We have multi-day report. You can handle it that way. You can enter a significant weather report that says from excuse me, from your window, it looks like you have about a 1/4 inch of ice. You can't get out to the rain gauge check. And there's lots of ways you can convey information, but you don't have to risk your safety by going out and injuring yourself trying to retrieve your rain gauge. So let's go through the review of this snow measurement. And this is this daily report form, sort of reassembled from the parts we had as we went through the program. You want to melt the snow and ice in your rain gauge, and your gauge catch is your daily precipitation. Then you measure the 24-hour accumulation of new snow on your snowboard. The yellow ones are all the primary observations. In this case, it's 4.2. And then if you're inclined, and by the way, you don't have to do this, but if you can, and it's convenient, we would like it, like you to measure the 24-hour SWE if possible. You take a core, you melt it and report it in the new snowfall section on the report. And if you don't cut a core, leave it as an A. Don't copy your rain gauge amount in there. And also don't enter 0 in there either. Then you measure your snowpack depth. And then if it's, for example, it's Monday, or this is the first snow or new snow, then you want to report the snowpack snow water equivalent if you can. But again, that's optional as well. If you're headed for work when you do your job in the morning, you won't probably have time to do some of this stuff before you go. But if you're able to, great. They're not required, they're optional, but if you're going to do them, we want them done correctly. So some tips for winter weather measurements. This is probably number one. An extra outer cylinder is a time saver. And if you have gone through a winter using an alternate cylinder, extra cylinder, you'll never go back. And it's not just winter, it's summer as well. If it's pouring rain at ob time, you can swap out a gauge and bring the other one inside, hardly missing a beat, and still have your measurement. But if it's snowing at the time of your ob, you are not going to have time to go in, melt what's in there, measure it, and then go put it back out before you have who knows how much snow additional. So being able to go out and swap out your cylinder is really nice. And you can buy the cylinder alone from Weather Your Way. So if you're so inclined, check that out and you can get a cylinder. I have 3 that I use. And not just so that I'm measuring a cord, I'm measuring the snowpack as well. So that's why it makes it easier. It's just, you go outside, you swap your gauge, come back inside where it's warm and nice, and take care of the rest of the observation. And it's also nice for cutting a core for your SWE without having it. Let's say the snow has stopped and you're not worried about missing anything, but you can bring your extra cylinder out there and cut your core and bring in your gauge and bring in your core, and then do the melting and measuring once you're inside. Weighing your snow or the water in your rain gauge is really a quick and accurate way to obtain the liquid equivalent. If you're looking for your gauge catch, snow in that gauge, and if it's a wet snow, for example, if it's a heavy wet snow, that will take a long time to melt if you just leave it on its own, or it will take a lot of extra water to melt that snow because it's so dense. And you're going to be doing a lot of pouring back and forth and subtracting what you added, keeping track of what you added, not spilling. You weigh this. If you weigh your rain gauge and your snow, you solve all those issues. What you need to do is you need to know the weight of your empty cylinder in grams. A good kitchen scale measuring to the nearest gram will work just fine. I have one I've had for several years. I have a set of weights to check its accuracy, and it's spot on. Once you weigh your gauge, you write that weight on the bottom with a permanent marker, 400 or 500 grams, whatever it happens to be. And that's on there. And I would weigh it every year, because I think they outgas and they do lose some mass. So you probably should weigh it every year before the season starts and check the weight. And then you have your cylinder outside, you go get it, it's full of snow. You bring it in, you put it on the scale and you weigh it. And what you're getting there is your gross weight, the weight of your gauge plus the weight of your water and the weight of your snow. You subtract the weight of your cylinder from this number. You divide that result by 201, which is the weight of water in grams that is filled to the 1-inch mark on our entering measuring tube. And then that result is the amount of water in inches. So an example, the cylinder plus water is 566 grams. The cylinder alone is 453. So we subtract that from 566 and we get 113 grams. So that's what our water weighs. And with water, snow, whatever in the gauge. To convert that to inches, you divide 113 by 201 and you get 0.56 inches of precipitation. And that's it. And you can do that for your core from your SWE. You can do that for your snow in your cylinder. There's no pouring. There is no spilling, unless you spill it before you weigh it. But it works great. And I resisted doing this for a long time. Not sure why, but I did. But once I started, can't remember the last time I poured, except maybe to do a spot check here and there. Even during the summer, I get my gauge overflows, my inner tube overflows. I get a couple inches of rain. I measure what's in the inner tube and I weigh the outer cylinder with the water in it and do the conversion. I don't do any pouring anymore. It's really slick and it's simple, and it just eliminates a lot of room for other errors. You do have to be careful that you measure your cylinder correctly, that you got the right weight, and that you do your subtraction. But no matter what we do, our subtraction division calculator works for that. And most phones have calculators. All phones have calculators, and it's really easy to do and saves a lot of time. I mean, some people don't enter their snow water equivalent in for hours because they're waiting for the cylinder, the snow to melt in the cylinder. With this, it's done in a few seconds, and you can get your observation done and entered really quickly. So we do have a lot of training resources on the web. For those of you that have only experienced CoCoRaHS through the mobile app, I hope there's not that many of you out there that have that little exposure, but we have a ton of stuff on our website, and we have these great little animations that break down the precipitation and snowfall measurement into separate steps. As you can see, each of these animations is 2 minutes or less, and we can have one that covers special situations that's a little bit longer, but that will cover some of the stuff we talked about here and probably some additional stuff as well. But you can review these at any time, and on the website. You need a refresher, you can do that. And we also have some other stuff too that's a little more involved. A much more involved presentation on in-depth snow measuring, which we'll need to be revising here shortly. But measuring that water content of snow by weight gives you instructions on how to do that. And also on how to measure ice accretion or freezing rain when that occurs. So that's all on the web. And as Noah said, this will be on the web as well. He'll provide a link to this program, and I believe also the recording that we're doing here. So with that, I'll be happy to take any questions either by voice or by chat. If you don't get a question answered or something comes up after this that you suddenly realize you want to ask, you can email me at that email address on the screen. And I think with that, Noah, we will go to questions.
Yeah, thanks, Steve. Nobody typed in any questions yet. I've been providing some links as the subject came up, and I provided a link to your slides here at the very end. as well. So everyone's got all these links that we talked about, but if you do have any questions, please type them in now to the chat. Or if you really want to go for it and unmute, you can ask your question that way as well. So we're here for questions at this point.
I did have one that was direct message to me. Asking, what do I mean by a core? What I meant by core, and I should have realized I was sort of slanging it there, but the core is that disc of snow that we cut out of the snowboard to measure the snow water content. So that core of snow, because you're not taking a big shovelful, you're taking a specific amount at a specific depth. And so that's what we call the core. That amount you remove by turning your cylinder over and removing it from the snowboard or from the ground if you're measuring snowpack. I hope that answers your question. Anything else?
And yeah, so someone did ask, and I'll send the link to everyone. We did record the previous version of this same presentation earlier this week, and we posted it on this playlist. It's on there now, but I think tonight's was a little bit better, Steve, if you don't ask me.
The audio quality the other day was not good because I didn't have the right mic selected. So this is much better in terms of audio quality.
Well, your bandwidth wasn't perfect tonight, but I think the content and everything was, for whatever reason, I thought was a little bit better. So we'll put this on that YouTube playlist. The one from a couple nights ago is currently on there, but we'll probably replace it with tonight's. So anyone else have any questions? Someone did say, what determines a register location? So as far as like, I'm not sure if I understood the question properly. What determines possibly, Steve, what Lynn is asking is, can I maybe take if my representative snowfall isn't right next to my rain gauge, how far away from my house could I maybe consider a good location? I'm just kind of trying to read Lynn's mind here with what she typed in here.
That's a good question because we get that from time to time. Yeah, and when we get windy snowfalls here, that will tell me where the wind direction will tell me where I'm going to make the measurement in the yard, because the way my house sits, it shields in certain wind directions. It's probably the case with most people. So if it's going to if it's going to shield the south end of my yard because it's a strong north wind, I won't be measuring the snow there because part of that will be very thin or bare because the wind blew it out. So you have to find a place that looks representative. Does this look like the snow that I thought fell? You might have a lot of drifts. We had somebody the other night that said, I live out on a farm and I go out there and there's 3-foot drifts in some areas, and in other areas it's white to bare, and in between it's spotty. Well, and then there's some situations that are going to be very difficult, and pretty much you're just going to have to try and do the best you can. And sometimes that's just throw up your hands and say, I can't figure this out, and just describe what you see in your comments. But a representative area is hopefully not too affected by wind where that, all the snow is piling up there and nowhere else. It really depends on the situation. And, for most light snow situations, we typically don't have a lot of wind in places. So those are somewhat easy to measure. The ones that really give everybody, including me, problems are the big storms that have lots of wind and it snows for 12 hours or whatever. Those are really a little bit trickier to measure, but sometimes you just have to stand outside, look around and say, okay, I know we had, 8 inches of snow at least, or 6 inches, or whatever case may be. Well, does this look like what I'm expecting to see? And where would I get representative measurements? And you might have to take 10 measurements, and somewhere it's 2 inches and somewhere it's 14 inches and somewhere it's 6 inches, and just do the best. You average those and say, this is what I measured, this is what I got, but it's, it's chaos out here, and this is the best I can do.
The
And
CoCoRaHS,
really, that is the way it goes sometimes.
the CoCoRaHS mantra, do your best.
Yes. And be
We've got
safe.
one last question. I know we've gone 10 minutes over our full
Oh, that's
hour
okay.
here, but one last question. Can we use can someone use a second snowboard for their total snow on the ground?
Oh, glad
And
you mentioned that. Good question, because I did bring that up the other night and I forgot to tonight. No, in general. That might work for your first snow and the next day, but once snow starts to melt and you get differential heating on the ground, and you got patches of ground here that have snow and patches over here that don't, we're not measuring the snow depth. The snowpack is not representative of a 2 foot spot on the ground. It's more you're trying to represent the area, and that's subject to interpretation too. For example, I have a 1 acre lot, and I live in a small area where there's 6 houses, all about the same acre lot. And I can look through the whole area and say, okay, the ground is about 60% covered. And I'll measure the snow in places, and I'll estimate, I'll make my snow measurements. And then from that estimate of coverage, determine what percentage of the ground is covered. If you're married to that second snowboard, you are not going to give a representative measurement. And if it's not located in a good spot, if it's in a shady spot, it won't melt as fast. If it's in a sunny spot, it might melt faster. So in general, except for I sometimes have out 2 snowboards, but I use it more as a backup, so that if my one board is blown clean, maybe the other one wasn't, I don't have them in the same spot. Maybe the second board is not as badly affected. But for total snowpack, no, I would not use a single snowboard to make your measurements, because other than the first one and maybe the second one, once you start getting the settling and melting going on, you're not going to be making a representative measurement.
great. And he said, I wanted to confirm it's acceptable to be hit or miss on the depth measurements throughout winter. I travel for work a bit. As much as I want to provide those daily depth measurements, I won't be able to. So will it affect the yearly data if my data is missing days and events?
Um, if you're missing reporting snow depth, no. Now, we have a lot of observers that take the winter off. I mean, literally, they just stop reporting in November and come back in April. And we have quite a few observers who don't or can't mess with snow during the winter, so they don't. They'll go get their gauge because it's convenient to get, and they'll take the measurement. So the snow measurements aren't required, and if you miss those, it's because of travel or whatever, that's fine. If you're gone and you aren't even measuring your gauge catch, when you get back, you can melt down what's in your gauge and then report that as a multi-day total. And then all your days will be covered and you won't be missing anything. Hope that explains it. If not, you can drop me an email. I can help you out on that. Or Noah
Yeah.
can.
And I would also say, I mean, if you miss days and aren't able to submit your multi-day, it might affect your annual total, but in general, any day you're here to submit data, it's
It's great.
fantastic. And
Mhm.
if you're not and you don't, we're not coming after you. We're not coming to knock on your door and ask you why you're not measuring for us. So um, I've posted our email addresses. Steve is hberg at CoCoRaHS. I'm Noah at CoCoRaHS, and then our general help desk is info@CoCoRaHS. So we really appreciate you guys all taking time tonight to be a part of this webinar. We'll stick around for maybe another couple of minutes, but for the most part, I'm going to actually stop recording now and thank everyone and wish you all a great night. And thank you again for being part of CoCoRaHS.
Have a great winter.